The images in this video were generated with Stable Diffusion. Stable Diffusion can be used to make images from text prompts, such as a description of a scene or a person. Stable Diffusion makes these images by using a deep learning algorithm to generate an image from the text. I thought these images would show an interesting and inspiring way to view what amazing things these algorithms can do. All of the information generated here will be made by GPT. GPT-3 is an artificial intelligence AI tool developed by OpenAI. It is a natural language processing system that was trained on a large amount of text data. It is capable of generating human-like text and can be used for a variety of tasks, such as summarizing text, generating translations, and answering questions. It has been hailed as a breakthrough in AI research. GPT-3 can be used to generate original text with a greater degree of accuracy and fluency than any other AI system. GPT-3 can be used to generate text for a variety of purposes, including content marketing, web content, and blog posts. GPT-3 can also be used to generate creative original stories and dialogue. The development of AI began in the 1950s with the work of Alan Turing, who proposed a test to determine if a machine could think like a human. This would be known as the Turing test. This led to the development of early AI programs such as ELIZA, which simulated conversation. ELIZA was an early natural language processing computer program created by Joseph Weissenbaum at MIT in the 1960s. It was designed to simulate conversation with a human user by using a simple set of rules and responses based on keywords in the user's input. ELIZA was one of the first programs to demonstrate the potential of natural language processing, and it was an important step in the development of artificial intelligence. Despite its simplicity, ELIZA was able to hold convincing conversations with users and even trick some people into thinking they were talking to a real person. Later in the 1960s, researchers developed more sophisticated AI programs, such as the General Problem Solver. The General Problem Solver GPS was a computer program developed by Alan Newell and Herbert Simon at Carnegie Mellon University in the late 1950s and early 1960s. It was one of the first AI programs to attempt to solve a wide range of problems using a systematic, general-purpose approach. GPS was able to solve a variety of mathematical and logical problems, but it was not able to deal with problems that required significant amounts of domain-specific knowledge or common-sense reasoning. Despite its limitations, GPS was an important step in the development of AI and laid the groundwork for many of the AI systems that we have today. In the 1970s, AI research shifted to focus on expert systems, which used knowledge-based reasoning to solve problems. Expert systems are computer programs that are designed to mimic the decision-making ability of a human expert in a particular domain. They typically use a combination of rules and heuristics, a set of guidelines or rules of thumb to make decisions and provide advice based on the available data. Expert systems were developed to solve complex problems in areas such as medicine, finance, and engineering, and they were able to provide solutions that were as good as or better than those provided by human experts. However, they were limited by their reliance on pre-programmed rules, and were not able to adapt or learn from new data. In the 1980s, AI research focused on neural networks and machine learning. This led to the development of deep learning algorithms in the 1990s and 2000s, which have been used to create powerful AI systems that can learn from data and make decisions without human intervention. To first understand machine learning, we will look at the definition of machine learning. Machine learning is a field of artificial intelligence that uses algorithms to learn from data, identify patterns, and make decisions without being explicitly programmed. It is a type of artificial intelligence that allows computers to learn from experience and improve their performance over time without being explicitly programmed. Machine learning algorithms can be used for a variety of tasks such as classification, clustering, regression, and prediction. Machine learning algorithms are divided into two main categories: supervised and unsupervised. Supervised machine learning algorithms are used when the data has labels or classes associated with it. The algorithm learns from the labeled data and can then be used to predict labels for new data points. Unsupervised machine learning algorithms are used when the data does not have labels or classes associated with it. The algorithm looks for patterns in the data and can then be used to cluster similar data points together or identify outliers in the dataset. In order to use machine learning effectively, it is important to understand how the algorithms work and what types of problems they can solve. It is also important to understand how to evaluate the performance of a machine learning model so that you can choose the best model for your particular problem. Finally, it is important to understand how to deploy a machine learning model so that it can be used in production systems. Artificial intelligence has helped create very powerful GPT modules that help answer very complex questions. GPT stands for Generative Pre-trained Transformer, and it is a type of natural language processing (NLP) model that uses deep learning algorithms to produce human-like text. GPT models are trained on large amounts of text data and can generate text that is similar to the input data. GPT models can be used for a variety of tasks such as summarizing text, generating questions, and generating stories. GPT models are also used in applications such as machine translation, question answering, and dialogue systems. One company paving the way for AI to help people is Neuralink. Neuralink is a company that is developing ultra-high bandwidth brain-machine interfaces to connect humans and computers. The goal of Neuralink is to create devices that can be implanted in the brain to allow for direct communication between the brain and computers. This technology could potentially be used to treat neurological disorders, improve cognitive abilities, and even enable people to control machines with their thoughts. Additionally, Neuralink could be used to create a new type of human-computer interface that would allow people to interact with computers in a more natural way. Ultimately, Neuralink could revolutionize how we interact with technology and open up a world of possibilities for the future. Another example of an advancement in AI with deep learning is AlphaGo, a program developed by the Google DeepMind team. AlphaGo was the first computer program to defeat a professional human player at the game of Go, a complex board game that is considered to be one of the most challenging for computers to play. AlphaGo achieved this feat by using a combination of deep learning and Monte Carlo tree search techniques to analyze the vast number of possible moves in the game and make highly strategic decisions. This breakthrough demonstrated the power of deep learning to solve complex problems and has opened up new possibilities for AI in a range of applications. DeepMind is also working on another amazing technology called AlphaFold. AlphaFold is a protein folding algorithm developed by the Google DeepMind team. Protein folding is a complex process that plays a crucial role in many biological functions, and accurately predicting the three-dimensional structure of proteins is a difficult and important problem in computational biology. AlphaFold uses deep learning techniques to analyze the amino acid sequences of proteins and predict their three-dimensional structures with unprecedented accuracy. This has the potential to revolutionize the study of protein structure and function, and could lead to major advances in fields such as drug discovery and biotechnology. While some people may be against using artificial intelligence to generate art, I believe it is important to remember that none of this art would be possible without all the artists being creative on their own. Just like it was up to me to decide all the information in the video, the artist can create new amazing things people have yet to see. This information took a long time to organize. I hope that you have learned something and thought it was interesting. While these new programs are limited, I think we will be able to use them to learn many things, to research and teach all kinds of information to people who have never had access to this technology. I look forward to all the creative things people will make with these tools.